To Balvikan Bharti. Now we'll continue with a few more keys on ratios and proportion. The first of kind I already described, that is addendo, and the alternando basically. So with the help of alternando, I have shown you the derivation of addendo. The next kind of, it is a similar of all addendo is the, this will be third one, subtrahendo. Subtrahendo is just bit different from the addendo. If it is a by b is equal to c by d, then in this case it is equal to a minus c, b minus d. This can be also proved with this same corollary. You can say if a by b is equal to, we are taking c by d is equal to k, so that means a is equal to bk and c is equal to dk. Now if I put this a as bk and c as dk and this is b minus d, take b k common, will get b minus d, and the bottom it is already b minus d, you can cut and you will get k. So a by b is equal to c by d. If it is, then you can say a minus b, b minus c, means deducting the antecedents and deducting the consequence, so we'll get this result. Okay. This can also be reversed. This also the true, c minus a, d minus b. I need not to say, because if I take minus common from both the sides, minus minus will be cancelled out, and if you reverse it, this will also be correct. Okay. So the next one is called dividendo. In this, if a by b is equal to c by d, then we can call that a minus b by b has to be equal to c minus d by d, or b minus a by b also can be correct as d minus c. Both are correct. Now in this case, if this is equal to this is differently equal. I am not saying this is equal to this. In other cases, whatever I have computed there, the difference is equal to this ratio, but this case, these are equal to this, but these are not equal to this. Okay. Now this also can be proved by the method. From this, what I do, a by minus b, if I use this addendo formula, the ratio formula that is given, if I deduct minus 1 from both the sides, so this will give a minus b by b, c minus d by d. So that is this one. Or else what I can do, I can deduct, I can put minus sign from on both sides first, and I can add 1, so this will give the reverse one. So this also is correct. So both are correct, and I can prove it also. This also can be proven by the thing that I have taken an example, the help of this constant, where a is equal to bk, c is equal to ck. Now if I put a minus b by b, it is equal to a is equal to bk minus b by b, that will give you k minus 1. Now you see the ratio itself is changing, so I cannot equalize this equal to this, whereas if I do this, c is equal to dk minus d by d, that is equal to k minus 1. These are equal to each other, but that is not equal to, because the k is become k minus 1, so this cannot be said to be equal. So these are not same. So be cautious when you are using this kind of relation. So this relation is only possible accordingly. Dividendo is applicable. If this is this, then we can say with the semicolon a minus c, b by b is equal to c minus d by d. So this is dividend. The next kind is the the name is componendo. The name is bit difficult to remember, so I am just taking time to recall it. This is dividendo, this is componendo. Componendo nothing but the similar kind, but only thing is that it will be, instead of plus it will be instead of minus, that will be plus. This will be of similar kind. Understand? This also similarly you can prove by taking the help of, instead of minus, if you can add plus on both the side, you will get this relation. So a plus b by b, c plus d by d. So this is componendo. The next of the kind is alterando. I have already shown you, because alterando has helped me to solve the addendo. So that I already covered. The sixth one is invertendo. Invertendo. In this very easy to remember this one. A by b, if it is c by d, then if we inverse it, means invert means topple it or make it ups and down. So if I make ups and down, so b will go up, a will come there, so definitely it will be also to be inverted. So that means if I say 2 by 3 is equal to 4 by 6, so definitely 3 by 2 is equal to 6 by 4. If I revert both the ratios, it will be also equal. So this is comes under invertendo and invertendo. Okay. So the last one, which is of kind is different, and it is very universal kind, means very unique kind, I mean to say. This is a combination of componendo and dividendo. With this combination, this formula is being done. What is that? A by b is equal to c by d. So in componendo, what is done? If we plus this componendo, there you will plus this a plus b, and in dividendo you do what you do in componendo. A plus b by b is equal to c plus d by d. You will say this is first, and in dividend what you say, a minus b by b is equal to c minus d by d. Okay, so now if you club this together, if you divide 1 by 2 or 2 by 1, whatever you combine, 2 by 1, whatever you do, you will get some relation. What is that? This is relation of combination of componendo and dividendo. So if I do the componendo by dividendo, if I do 1 by 2, so what will remain? The b will cancel, this side a plus b by a minus b, and this side c plus d, c minus d. Okay, so this is componendo and dividendo. Now this can be reverse dividendo of componendo, because this is again, if we apply in this ratio the invertendo is just inverting the ratio. You will find a minus b by a plus b is equal to c minus d by c plus d. So this also will be correct. So attending dividendo componendo or componendo dividendo, you will get the result true, and if you inverted any of this invertendo, you will get either the relations. So this is the complete thing. Now this also can be proved easily by the thing, if you do take this one. So what would the case? 1 plus a plus b, a minus b. So you will find this is a is equal to bk plus b is equal to bk minus b. So ultimately this will become k plus 1, k minus 1. And if you do with c minus d, you will get c is equal to dk plus d and dk minus d. So ultimately you will get k plus 1, k minus 1. So both are same. So if this is true, this will be true. Okay, so these are the theory or the rule, you can say, on this. And so now I will give you some more corollary, basically, so that some concept may also can be established. That is not much difficult to understand, but still sometimes it is very essential to have this directly during solving the problem. So you just have to keep in mind that if any ratio is there, okay, any ratio is there, and if we multiply or divide with same number to both antecedents and consequents, the ratio does not change. It is very you can say easy to understand, but still. So what is that? If I say this a by b, if I multiply it with any other number, the same number, so it will change only to the value of the antecedents, but the ratio at the end will not be affected, as because the both can be nullified. So if I take an example, a by b is equal to 2 by 3. Okay, now this a by b, if I multiply both this with 2 to the antecedents and consequence, this will become, now the new thing will not be same. So the new thing, let me say it c by d. Okay, so the c by d, now let me take 2 by 3. Okay, now this 2 by 3 I multiply the 2 both, so this will become c by d, and it is become 4 by 6. So ultimately a by b, which was 2 by 3, I multiplying 2 by 3, 2 on the both antecedent and consequence, so that will change to some other ratio in the form c by d is 4 by 6. But ultimately if I reduce it, I will get 2 by 3. So that means the value respectively or at the antecedents and consequence will change, but the ratio, ultimate value of the ratio won't change. So in that case, this can be said true. So, and the same thing will happen if I divide it both with the same number. This also will not get affected, because ultimately this will turn into this. Okay, the same thing, means 2 by 3, if I divide by 3 on both ends, so that will give you the same result. Ultimately this is 2 by 3, so that will not change the value. So this is an corollary. Okay, this may be needed someone. Okay, so this is the first corollary. The second is that yes, product of mean is equal to product of extreme. This is also very much easy to understand, because if I say two ratios, a by b is equal to c by d, then these are called the extremes, these are called the means. So now what is that? If I cross multiply this, and this become equal to b into c, so that means what is product of the means? This b and c are the means, so this is the product, and product of the extremes a and d are equal. So if it is correct, this is also correct. Okay, this is the second corollary. But sometimes it is to be needed directly to be understood, so that's why This has to be kept in your sense. Now, if there are three quantities A, B, C are related in such a way that A by BC, A plus B plus C is equal to B by C plus A and C by A plus B are equal, then A is equal to B is equal to C if A plus B plus C not equal to 0. This is one different kind of relations, but this can be proved true. So if I am saying this, then A is equal to B is equal to C when this is. Now how can it be proved? Let me take. Now this is some ratios which are equal. So that means they are in proportion. So if you remember the invertendo means the reverse of these ratios also to be equal. If three ratios are equal, then the reverse also equal, that we know in invertendo. Now what we will do, we will add 1. So if we, this is also an corollary, you can say, after that production you can say this is also an corollary is that if you add or subtract same number from the ratios in proportion, they won't change relation. That means if I say A by B is equal to C by D, then if I add any number, add or minus, so this relation won't change. A by B plus minus n, a number, C by D plus minus n, that relation won't change. Relation will be same because that will not affect the whole relation. Only thing is that the value will change. So that is also a corollary that you can take the help of it and can solve several things. Now here I am just using that corollary and solving this. Now what I am doing, I am adding 1 to each, so it won't change the relation. So now if I do the LCM of every case, so I will get A plus B plus C in all cases. Okay, A plus B plus C by C in all cases. Now you again use the invertendo relation. So what I will get, if these are equal, so are equal. Now as I said, A plus B plus C if not equal to 0, that means these are real ratios. Then if all are equal, the bottom are equal, so definitely if the ratio has to be equal, then A is equal to B is equal to C must be there. So you can understand, if these are equal, so and if this is not equal, so this has to be equal. That can be proved. This is a specific one, so you can use it wherever it is necessary. So the next one, let it be 4. Now A by B is to C by D. There are one ratio, then again they are in ratios. Then what would be the result? So the in case the ratio formula is there, that means it is being divided. As we understood, A is to B, that means we are dividing A by B. So following the same rule, what I have to do, I put instead of this, I will put this as a sign. So then the divide sign can be converted into by reversing the consecutive ratios. This can also be possible if A by B is to C by D is to E by F, then what I have to do, this also follow the same in the next ratios. All will be converted similar way. This is the rule. So if I follow that same rule here, this will be converted and then it is become. So what is the result of A by B is to C by D? This and this is to multiply directly, this and this multiplied directly, and this will come. So that means the extreme will be multiplied and the means will be demonstrated and the result will be that. So this is one corollary. The next one, 5. Is that yeah. Now this is the extension of addendo where a by b is equal to c by d, then this is also equal to a plus b. So now what is the meaning of that? That means if I say, if I adding two ratios something in this case, now if I take the example you will understand, a by b, let's say this is 30 by 50, okay. So now c is equal to 3, d is equal to 5. Now what I can say, this ratio will be same as this ratio when the number we are adding, if the ratio of those number matches with the ratio of the actual number. That means a by b is a ratio of 3:5 and c by d also you can see it is ratio of 3/5. So if a by b and the number we are adding, those number in between, if I do the ratio matches, then only we can add and get the same ratio. Understand, this is just a other way of saying the addendo formula. Okay, understand, this will be very useful when I'm adding something, and if these are in the ratio of the same with a by b, then we can say the after the sum will get the same ratio as those two. Okay, this is also an corollary. The next one is if three ratios, unequal ratios, b by b and c by c, these are small letters, these are capital S, are unequal fractions, then the ratio of the summation of the antecedents to the consequent will lie between the lowest fraction to the highest fraction. Okay, this is one kind of corollary. These are the fractions. I don't know what is the value of these three. There could be one highest, one lowest, and now if I want to get the ratio of this antecedents, sum of the antecedents to the sum of the consequents, that will lie between the lowest fraction of all three and the highest fraction of all three. This is also an corollary. Okay, and anything else? There is one more. Till now I have shown the triplicate point and sub duplicate point. There are one more sub triplicate point, triplicate ratios also there, where if the ratio is in a by b, so for a by b the sub triplicate ratio will be cube root of a is to cube root of b. In other cases I have shown sub duplicate, where sub duplicate is square root of a is to square root of b for this same, and sub triplicate is, I forget. One more thing, the representation of the proportionate. If I say a is to b and double colon c is to d, that means is same as a by b is equal to c by d. So that means a by b in the same ratio in proportion to c by d, that can be signed as this double colon means the equal sign. Okay, in mathematics or in ratio and proportion. And something more is there, or else I will end this session. Length was not there. Okay, so this is the end of this session, and the next session I will start solving problem. Thank you for now.